This video provides an overview of the oldest light activity. Unlike training, when the user selects an activity, they'll land in the transporter room. They'll then be instructed to put on their spacesuit and then head over to the universe timeline footpad in order to select the activity from the timeline. So let's do that now. Placing on the spacesuit, footpad is highlighted purple. Once on the footpad, they can select the activities, in this case the oldest light, which is the one on the far left.
The oldest light.
Begin teleporting.
Hi there, this is Kirsten beaming in from U3D. I hope you can see my video feed clearly despite you being around 13.8 billion years back in time. Check out where you are on the timeline on our console.
So we've arrived at 10 seconds after the Big Bang and the temperature is 6 billion Kelvin.
You have also shrunk to the size of a cell to explore atoms and subatomic particles. So cool! You have arrived seconds after the Big Bang, and the young universe is scorchingly hot. Still, as it rapidly expands, it is cooling. At an atomic level, things are changing really fast. It is your job to find out why. But first, just look around you and observe the state of the baby universe. What do you see?
So as the user looks around, they'll see subatomic particles flying around.
To get an overview of the period you are researching, you and your console will now journey to 380,000 years after the Big Bang. Blink of an eye considering the age of the universe. This will take you only 30 seconds. Take a good look around as you travel through time. You will then come back to where you are now, and you'll be able to repeat the journey at your own pace so you can complete your research tasks. Push the play button to begin.
Okay, so the user will now be able to see the time period. Fast forward, so we're just going to press this play button to go through that now on the console. So they'll see a subatomic particles flying around, then the nuclei will start to form. And as time progresses, they all slow down until towards the end, the photons will fly off, there'll be a big flash, and the atoms will appear.
Now to your research. You need to identify and collect evidence that supports the most widely accepted scientific model for the origin and evolution of the universe, the Big Bang Theory. Don't forget to take snapshots of your results to complete your data collection. Good luck!
Okay, so the user will now be given their first task, which is to fast forward to about 20 seconds, pause everything in the universe, and then take measurements of each of the particles. So let's do that now. So around about 20 seconds, the pause button will become available. We press pause and all the particles in space stop, and then we can take their measurements. So first one, electron. Let's get the atomic information and take a snapshot.
Woohoo!
And we do this for the other particles. So photon.
Woohoo!
Proton.
Woohoo!
And neutron. Oops. Should have pressed the measurement then. Now let's get the snapshot. That completes the first task. The user is then given the second task to move between 2 minutes and 20 minutes and have a look at the nuclei that are forming and take measurements of each of the nuclei. So let's do that now. So we press pause to bring back the fast forward and rewind buttons. Let's head to about 2 minutes. I'm going to do 3 minutes, press pause, and we should start to see some nuclei that we need to analyse. So hydrogen, get the atomic information and take a snapshot.
Woohoo!
And as the user takes a snapshot or analyses each of the nuclei, they'll actually start to form or to present themselves on the bench to the right to us for the next activity. So let's keep doing that.
Woohoo!
Now at this point, a proton changes to a hydrogen. So let's get the atomic information of hydrogen.
Woohoo!
As we can see, they're starting to form on the bench. That just gives a hint to the user how many they've got to still find. So I might progress further to get a few more. So helium.
Woohoo! Woohoo!
So now we've got both helium. I think we need to progress a little bit further to find the others. So let's do that now. Okay, we've got another one here, which is beryllium.
Woohoo!
And then the last one should be lithium. So they're the same. There we go, there's the lithium. Okay, so we've now finished that task. We've got all the nuclei presented on the bench in front of us, and the user's now instructed to place them in order on the infographic in front of them. So let's do that now. So they simply use the scanner to scan the first one, hydrogen, and then scan where it should be located.
Woohoo!
We keep repeating that until the infographic
Woohoo!
is completed. Which one is it? Oh.
Woohoo! 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 Woohoo!
Okay, at this point they can now take a snapshot of the order.
Woohoo!
And now they get given a task, the second one, which is to look at the different time points and check the temperature. So let's do that now. So I'll go to 20 minutes to begin with. And then they can click on the infographic to fill in the temperature, like so. And let's do that for 3 minutes and 2 minutes.
Woohoo!
3 minutes. and 2 minutes.
Woohoo!
The user then takes a snapshot of the completed infographic.
Well done! You have made it through the first 20 minutes or so of the universe and observed the formation of the first nuclei. Scientists predict that at that time, something exciting occurred. The temperature and density of the universe fell to the point where nuclear fusion couldn't continue. What do you think happened then? Use the fast forward button on your console to travel forward in time and see how far you and your console get before you stop. Remember to look around you and make observations as you travel.
Right, so let me bring the scanner back. The user now progresses to the end of the time period to see what happened. So let's press play. Let's navigate to the end of the time period. So the user can see how everything changes around them. All the particles and nuclei are slowing down.
Okay, you are now 380,000 years after the Big Bang, a critical moment in the evolution of the universe. Not much happened between 20 minutes and 380,000 years, despite the universe continuing to cool and expand. Elemental abundances were nearly fixed, and the only changes resulted from the radioactive decay of the two major unstable products of the Big Bang nucleosynthesis, tritium and beryllium-7. But then, something did happen that really excites cosmologists. Did you see that flash of orange light at the end? What caused it, and where did it go? Well, that light continues to travel through the universe and is in fact the oldest light that astronomers can observe. But how? I'll show you, but you have one more research task to complete. Return to the transporter room when you are finished.
Right, so before returning to the transporter room, the user needs to take two snapshots. The first is the temperature, and secondly, what's happening in the sky, how the atoms are formed. So let's do that now. So we got a shot of the temperature.
Woohoo!
Let's get a shot of the atoms.
Woohoo!
And now we've completed that final task. So an icon will appear to tell the user they need to return to the transporter room, as Kirsten just explained. So let's do that now.
Begin teleporting.
Hi, welcome back. Grab and put on the electromagnetic spectrum visor from the bench on your left. It will click into place.
All right, so the user now needs to put on the spectrum visor, which is on their left on a bench. And they can do this by simply putting their hand over the top of it and then pressing the side trigger to pick it up, bring it up to their head, and let go of the side trigger.
What's the story behind all these colors outside U3D? Well, the light you saw emitted 13 billion years ago now looks like this. The photons continue to travel through the expanding universe, making up the oldest light we can observe. Wherever you go in the observable universe, this radiation exists, but as microwaves. It is called the cosmic microwave background. Why are there different colors? Point your scanner at the red and select the most appropriate button on your console to work that out. Then try scanning the dark blue. Remember to take snapshots of the results.
All right, so the user now uses the scanner and analyzes the information of both the red light, which they need to get the temperature of, take a snapshot, and then the blue light.
Woohoo! Well done! You have lots of data to work on back on Earth. How was it seeing the oldest light? It's time to return your spacesuit to the cabinet and return to Earth. See you next time in U3D.
Right, so now the user's completed the task, an icon will show to return to Earth. Before we can actually return to Earth, because it's disabled at the moment, we need to put our spacesuit back. So let's do that. Once the spacesuit's back, the button will be available and we can end the activity.